So welcome to this afternoon session on diving into Reactive. A couple things. First, thanks, Paul, for that awesome introduction to Kubernetes. Second, look at this. I got too hot, so I can't wear it. But I wanted to at least represent. For those of you who haven't noticed, it's true, I'm not Josh Long. We're often mistaken for each other in like airports and stuff. I'm kidding. Josh couldn't be here. He sends his apologies. He had a family emergency come up, for those of you who don't know. So if you would keep him in your thoughts, he's kind of struggling at this point, going through a little bit of a difficult time, but he wanted to be here with you, and I'm here in his stead, just doing what I can. So so let's talk Reactive, shall we? Again, my name, I guess I didn't already mention this. My name is Mark Heckler. I also am a developer advocate with Pivotal, and I can be reached at the following coordinates, which we'll get into later as well. So who am I? A little bit more about myself. I have authored several blogs and blog posts. I've co-authored a couple of books and contributed content and code to several other books, a few of which even recognize my contributions. That was nice. The rest of them, don't buy those, please. I also have another book coming out, which I will mention and go into a little bit more later. But continuing on with this, I am an architect and developer. Oh, you want me over here? I'm so sorry. I'm throwing the camera folks off. I like to amble. So I am an architect and developer, and as you might surmise from the next point, where most of my expertise has been won, it's been in the JVM ecosystem. Some Groovy, a lot of Java, some Kotlin. So we'll be staying kind of in the Java track today, but that's cool. If you're a Kotlin fan, there's a surprise for you at the end as well. I am a professional, I should back up a little bit. I am a Java champion, a Java 1 Rockstar, a Groundbreaker Ambassador, a few other honors and awards that, while very meaningful, still mean I have to buy my own coffee, so I don't understand. Anyway, I am a professional problem solver. It's not my official title, it's just what I do. It's what you do, right? It's what we all do, that's why we're here. But I am a Spring developer and advocate. I commit code. I like to talk about code, so I kind of get to do it all, and it's something I'm grateful for. I am also the sole creator and curator of Spring Noticias en Español, so if you're a Spanish speaker, talk to me. If not, that's fine too. Talk to me anyway. Okay. So about that new book, I'm going to be working on a book next year. I'm actually trying to stay home a little bit more the first half of the year because I have promised to create a book in a matter of only a few months, but we're targeting August 1st for the ship date on that book. This is not the real cover. This is just an artist's rendition. It's a parody cover. I was looking, the title will be Spring Boot Up and Running, and I'm going to be covering all kinds of things to get started with Spring Boot as well as continuous Spring Boot and deepen your knowledge and expand it and even go into reactive stuff as well, obviously. But I was looking for, with the title being Spring Boot Up and Running, I was looking for a running monkey, and this is the closest I could find. That's me, by the way, I'm the running monkey. So hopefully they won't stick me with this cover now, I don't know. But if you are interested in knowing more about that, follow me on Twitter, mkheck. That's the best way to reach me. That's where I do all my announcements and just inane chatter. So today, we're here to talk about reactive programming and reactive systems. I like to start with this because it's one of our Project Reactor team members. I'm straying again, I am so sorry. I get animated. It's more fun when I can walk and talk, right? Okay, so I'm trying to anchor myself right here. Okay, in a nutshell, this is a quote from Rossen Stoyanchev, one of our Project Reactor team members. And Rossen threw this out a long time ago, and I loved it, and I've used it ever since, much to his chagrin. But I like it, right? It says, in a nutshell, reactive programming is about basically three things. Non-blocking event-driven applications that scale with a small number of threads, with back pressure as a key ingredient that aims to ensure that producers do not overwhelm consumers. Now, that's a lot of stuff packed into one statement, so let's unpack it a bit. In the Java realm, we have typically had one way to scale over time, which is spin up another thread, right? For each additional connection, we have an additional thread, and that works great up until you hit that max number of threads. At the point that you hit n+1 number of threads, something happens, right? Someone waits, and that could be a long wait, right? In the meantime, all those other n threads are doing what? Well, they're probably not doing much, right? Because they're blocking and waiting for something else. They're waiting for a response from another service or a database call or a file system call or what have you. So what you see is a very efficient mechanism to reason about, but a terribly inefficient mechanism for scaling. In a reactive space, we look at ways to scale with a small number of threads. So we don't tie up a thread. We tend to shift off of it. We insert an event loop so that when we have a request and there's some waiting state that needs to happen, that thread isn't monopolized, right? It's released and it can go on to process other requests and do other things. And then when the response is ready, it picks up and sends the response back. Back pressure is a key ingredient because up until now, what we've talked about are things that can be associated with asynchronous programming. Now, if anyone's done asynchronous programming in this room, first, I'm sorry. Asynchronous programming is not all that easy. It's not all that clean. There was a term coined a long time ago called callback hell, because typically you use callbacks, nested callbacks to handle this. So you're waiting for a response, and when that response comes, then it makes a callback to this function or method, and so on and so forth. And over time, you get these rather radical-looking structures of nested callbacks, thus callback hell. The other problem with asynchronicity is not just the readability, right? The other problem, of course, is that when you have a purely asynchronous exchange, if the producer of values sends just a ton of values back to the consumer, and that consumer can't handle that number of values, what happens? The consumer typically just falls over, right? It dies, which is a real shame because consumers are so hard to find nowadays. But there should be a way, and with reactive programming, there is a way for that slower consumer to say, look, I can't handle 1 million records. I can only handle 5 or 10 or 100 or 1,000 or whatever that number is. And that way, that slower consumer can process that number that it can process, and then when it's ready for the next set, it requests the next 5 or 100 or what have you. So that gives a way for those interactions to happen, and a slower consumer won't be overwhelmed by a faster producer. It does not, however, fundamentally change that you have a fast producer producing hundreds or thousands or tens or millions of records of data values it's pushing down the pike. It just changes the fact that you don't have to necessarily try to absorb all of them on that slower consumer, right? There is a way to broker that a bit. Okay. All of this is predicated on reactive streams. The Reactive Streams Initiative was entered into by a lot of different companies who saw this problem coming and felt that rather than solve this problem in various different incompatible ways, they would work together to come up with a solution that could be interoperable. So companies like Lightbend or TypeSafe at the time, Red Hat, Twitter, Kazing, Pivotal. You've got a lot of major companies who said, look, we can do something about this, and let's not just be jerks about this. Let's work together and make sure this all works properly in the interactions. So the Reactive Streams Initiative focused on the streams, those interactions where blocking typically occurs. And there are 4 interfaces defined in reactive streams, just 4. And there are 4 interfaces, by the way. So there's the publisher, that's the thing that produces values. The subscriber is the thing that consumes values. The subscription is the contract entered into between subscriber and publisher. And then your processor incorporates both subscriber and publisher because a processor will receive a value, manipulate it in some way, and then pass it on, right, to its subscribers. So it's very simple, it's very granular. It's also 4 interfaces. So if you want to take advantage of and leverage a reactive streams implementation, you have to do what? You have to either create an implementation, which there's a lot that goes into that. There are a lot of operations that kind of make sense within a reactive streams context, or you can leverage one. You can use one that already exists. Now there are several on the market. Arguably the best one is Project Reactor. Project Reactor is something that Pivotal came up with, but we have wide industry support. Companies like Microsoft have standardized on that within Azure. We have something that I'll actually be mentioning here momentarily, RSocket, which is standardized upon Project Reactor's implementation of reactive streams. It doesn't say anything bad about the rest. It's just for whatever reason, we've got a pretty compelling implementation. And we pour a lot of effort into making sure that stays at the front of the pack, right? So, what else? Because so far I've talked within an application, right, to some degree. You also, when you talk about a reactive application, that's great. It tends to increase your scalability and in some ways some performance, right? Because I typically have kind of avoided mentioning this or skipped over this a bit, because you shouldn't necessarily look at moving to a reactive implementation for performance gains. But that doesn't mean in some certain circumstances they aren't there. Because if you make 3 calls to 3 different services from service A, well, I should do it this way, right? Service A calls service B, C, and D, and each one takes 1 second to complete. So if each of those takes 1 second, and service A calls service B and gets a response, calls service C and gets a response, and calls service D and gets a response, what's the minimum response time for service A for an incoming request? Minimum, I know math is hard, right? Come on, help me out, Paul. So 3 seconds minimum, right? It has to make 3 different calls plus a little bit of overhead time. But if you could parallelize those, if you could fire those off and assemble the responses when they came back, what is your new minimum response time? 1 second, right? So there are real performance gains to be seen, not in every circumstance, but they certainly exist. The big news, though, is in terms of scalability, because instead of dealing with that n number of threads, you can actually deal with a far greater number of connections, a far greater number of requests coming in, because you're not sitting on threads and tying them up. So what else? Because now that we've kind of covered the nucleus of it, you need some way to deal with databases that is non-blocking, because up until now, if you have requests coming in and they're not blocking, and you're processing and that's not blocking, and then you're waiting for a database that's blocking, what have you gained? In some circumstances, not a lot, really. You've added a bit of complexity to it. You're changing the way you approach things, and you've got a blocking interaction with the data store. Not great. So we needed some method of reactive database access. Now, the good news is there are a lot of options in this regard now. In 2019, we have great options. So Couchbase, Cassandra, Redis, and MongoDB offer fully reactive drivers. So we can interact with those data stores without blocking. We created a project, an initiative with several others in industry, but we led this called R2DBC, the Reactive Relational Database Connectivity effort. And this allows us to work with SQL databases in a non-blocking reactive way. So things like Postgres, MySQL, MS SQL, H2, and more, right? So these are coming on, right? They're not fully baked, they're in all cases, but they're coming on strong, and they're looking better and better with each passing week. RSocket, this is a great story as well. RSocket was created by a group of engineers out of Netflix. We've got Netflix, Facebook, Pivotal, Netify, all contributing heavily to RSocket to make sure that that network boundary doesn't pose a problem, that we can apply back pressure even across the network boundary, which really gives a lot of capabilities. RSocket gives you the ability to resume connections. So when you are, let's say, well, as I mentioned, Facebook is using this for their mobile app. So I'm not a huge Facebook fan, to be really honest, but they're doing some really cool things with their mobile app. So if you know when you leave your home and you're on Wi-Fi and maybe you tap Facebook to get the update as you're walking out, and then you drop off Wi-Fi and you switch to your phone connection. In the past, Facebook would start over, right? If it were updating your feed at that point, it would just start over and re-download everything from zero. But with RSocket, it can resume that connection via a different connection, right? So when you drop off Wi-Fi and onto your cell signal, it just says, here's where I was, give me what I'm missing, that's it. Which is huge, right? You talk about data savings and bandwidth savings, that's massive. RSocket gives you some other things as well. It allows full duplex, both bidirectional communication. So instead of a request and a response, you have 4 different mechanisms you can use. A request response, which is one way, like one interaction, right? One request, one response. You can have a fire and forget, so you just send something. You can have a request and a stream, so you make a request, you get back a finite stream. And then you have a channel, which means anything goes, right? You can make a request and get back just an infinite stream, or you can make multiple requests and they can originate from either end, because it's a truly bidirectional protocol. It's a truly bidirectional implementation, which means that once that connection is initiated and made, either side can initiate communication. So there is no longer a client and a server, so to speak. there's just requester and responder, regardless of which way it comes from. It's incredibly powerful. I'll give you a little taste of that today. Hopefully we have time. We're looking good on time. Testing, debugging, blocking call identification, because Reactive does add a bit of a different mindset to your coding. I mean, Spring makes it easy. It's true. And Spring makes RSocket dead simple as well, too, by the way. If you've tried RSocket, but outside of Spring, you might look at the overhead that implies. Inside Spring, it's pretty nice. Really nice. Same thing with your blocking call identification. We have a tool called Blockhound that when you think you're non-blocking, you insert this as a dependency, you test out your code, and it tells you exactly where a blocking call is lurking, which is huge, right? Microsoft uses that for their tools as well, which is, again, very nice and very nice endorsement. And more. There's so much more, but time. So we're going to code. This is how I like to see things. Well, not like this. Okay, this is bad. This is clearly bad. Does anyone recognize this gentleman? This is Maurice Moss. It's from a series called The IT Crowd. It's a British comedy series from several years ago, actually. It's a little old now, but it's still so funny. So if you can look it up on Netflix, or I don't know if it's on Netflix here or if it's not, but if you can find it somewhere, it's well worth your time to watch. This is one of the heroes of the IT Crowd, Maurice Moss. And he's dealing with, well, okay, hopefully not what I'm going to be dealing with. Anyway, so let's get started coding. So I'm just going to go here. And this, I wish Josh were here. I could try, you know. I mean, this is the Spring initializer. This is the second best place on the internet. The first best place on the internet is production, right? Josh would tell you the first best place on the internet is production. The second best place is this, and this is the Spring initializer, start.spring.io. I'm not going to go through all the stuff that it can cure for you. I'm just going to tell you that if you want to start off making Spring Boot-based microservices, this is the place to go. You don't have to go here. You can use your IDE. You can curl this. You can write them all by hand painstakingly, like children. But you don't have to, right? This is a great jumping off point. We created this for a reason. It also has a couple neat things like dark mode. I love that. I know, it's the simple things, right? Can everyone read this if I keep it there? If not, I'll switch it back. No complaints. Dark mode it is. Okay, so you have to speak up. If you can't see something, just please let me know. Okay, so we're going to create some very simple things here today just because I want to not focus on the stuff. I want to focus on the things that I want to share. So we're going to create a Java project using Maven. We're going to use the current version of Spring Boot. I'm going to change this to thehecklers.com because I can. And I'm going to create a coffee service because I live and breathe and drink coffee. I have my fuel here. I hope everyone else does too, which, by the way, okay, now we can proceed. All right, so there are options here, right? Options are not necessary. They are called options for a reason, but we can fill this out should we want to. There are a couple different packaging options. Please don't use war. If you have to, I guess I understand, but please don't. We do jars for a reason. It tends to go with that whole 12-factor thing and makes your application that much more cloud-friendly. We can talk about that later. But your versions of Java, you have options as well. Version 13 is the current version of Java, right? That's the one that they throw out for 6 months and then they throw it away. But your long-term support versions out here are 11 and 8. 8, of course, still has support. We baseline on 8. 8's a solid version, and there are a lot of you probably using this in a lot of applications. However, 11 is the current long-term supported version of Java. If you're not on Java 11, I would recommend you get on it. Again, 8's fine, but we'll go with 11 today because 11's better than 8, right? And then I'm going to just bring in a few dependencies. So I'm going to, let's see, what do I want? I want reactive web. Let's see, and I want, let's see, what do I want? I want RSocket because we want to show that here in a little bit. I also want reactive MongoDB. Because you have to use a database for something. I might as well use Mongo, right? And I'm going to bring in embedded Mongo database because it makes my life a little easier as a developer and because, well, I'll tell you in a minute. It's fun. It's fun. And then I'm going to bring in Lombok because I'm a lazy developer. Lazy good, not lazy bad. I just want to be very clear about that. I don't necessarily encourage people to use Lombok in production for several other reasons. It's not terrible, but they occasionally will issue a breaking change on a dot release, which doesn't exactly make me thrilled. But it works really well for demos because it allows me to isolate again and focus on the code that I want to focus on. So we're going to just generate our project here. And we'll just drop that on the desktop. And that's our coffee service. And just because I want to be able to come back to this quickly, I'm going to create my coffee client as well, because we will do a client. We won't need database access for our client because obviously we have our service for that. And I'll save that down as well. Let's go ahead and open up our, here we go. We'll open up our application. Oh, I have other stuff I didn't close out. Let me close that out. Boom, boom. And there we go. Okay. Well, come on. Well, that's terrible. Okay, let me try that again. So, yes. Okay, so I use IntelliJ. It really doesn't matter what IDE you use. Oh, who am I kidding? Please use IntelliJ. NetBeans is also good. Not a big fan of Eclipse. It feels like that Swiss Army knife with a million blades that you can never find the right one. But, you know, it's a great, okay, it's an IDE. It's fine. I'm actually going to blow this up a bit so I can, so the folks in the back can see this a little better. I have it set for high contrast already. I just forgot to make this bigger. So is that better? Can everyone see that? Sweet. Okay. So the first thing I'm going to do is go to my application. And let's write some code. So if we're creating this application as a coffee service, we should deal with some coffee, right? So I'm going to create this class. We'll call this coffee. So this is our domain, and our coffee should have an ID, and our coffee will probably have to have a name, right? And I'm going to use Lombok again because I'm lazy. I'm going to ask Lombok to create make this a data class, so it gives me my getters, my setters, my equals, hash code, and toString methods. I'm going to ask Lombok to provide a no-args constructor for me, a required args constructor, which means that anything I indicate as a not null value, it will provide a constructor that just has that, and then an all-args constructor, which basically says, hey, look, give me a constructor with every member variable as a parameter. So it covers all the bases this way. I'm going to indicate that this is my ID field. Yeah, let's try that again. Mark, @ID, that's much better. And then I'm also going to indicate that we're going to save this in Mongo as a document. Pretty simple, right? So it's a fairly straightforward use case. Lombok makes it a little bit cleaner. I'm also going to need some operational data here. So I'm going to, once again, create another class, no-args constructor and all-args constructor, and this will be our coffee order class because this allows us to track the orders that are being placed for each particular coffee. If we have a coffee that's being ordered a lot, right? So across all of our different coffee shops, if a coffee's being ordered several times a second, that's a good coffee. We probably want to stock more of that. But if we have a coffee that's never being ordered, we can drop that from our catalog. So we need to know that kind of stuff. So with a coffee order, we have a coffee ID, right? And a time of ordering. So keep track of that with an instance. So when ordered. And that should do it. So that's our domain, pretty simple domain. Next, we need to be able to store this in a database. Well, Spring Data includes a concept of a repository. So we'll create a coffee repository, and we'll extend our reactive CRUD repository interface. Now, Spring Boot's autoconfig, when it sees you've extended an interface defined in Spring Data, says, hey, I bet you want to talk to a database. You have a database driver in your class path, right, Reactive Mongo. You have an interface from Spring Data that you're extending. Let me create a proxy bean for you so I can interact with your data store on your behalf. We're going to be persisting objects of type coffee and IDs of type string. And that gets us what we need, at least for the time being, for this. Now, if we want to see what's going on, it'd be really cool if we had some kind of a data, sitting out there. Oh, and before I forget, I need to do one other thing, which I kind of skipped over here. So I mentioned that I like embedded Mongo. It comes in at just test scope, which we don't want to just do test scope. We want to actually run this against it. But the thing that I love about embedded Mongo, well, one, it works. Okay, that's the primary. But the second thing is just the name. Flapdoodle. This was created by a German fellow, right? And we all know Germans are well known for their sense of humor. Okay, that's a joke. My heritage is German. I feel like I can say that because my jokes are terrible and you just proved it. It's fine. But I love this. Flapdoodle. It's just funny. I can't even say that without smiling. Just flapdoodle. So we're going to use embedded Mongo. That's fine. And we're going to create some data to push into that. So I'm going to create a class called data loader. And I'm going to inject my coffee repository. We'll call this repo. Now, with injection in Spring, you can do what? You can do field injection, but that's evil. Don't do that. Don't do field injection. It's not eminently testable. So you can do a constructor injection. So I can create my own constructor, or again, lazy, I'm just going to ask Lombok to create an all-args constructor. Since this is a member variable, it'll create a constructor with this as a parameter. Done. So nice. Okay, so with that, let's go ahead, and I'm going to create a post construct method, and we're going to load some data. So load data. Now, what I want to do is create a flux of just these values. So we need some coffee names. I'm going to start off with a favorite of mine, Café Cereza, which is from Colombia. Very nice coffee. If you get a chance, please try it. Don Pablo, also another very nice coffee. We have Sumatra, which is an excellent roast as well, an excellent coffee variant. Let's see, we have Caldi Coffee, which is from my hometown of St. Louis, in the middle of the U.S. Not exactly known for coffee, but it actually brings in some nice beans and roasts them elegantly. It's a nice flavor. And then Kona Coffee from Hawaii, also a nice one. So we're just going to create a flux of just these coffee names. I'm going to map each of these names, because this is just a name, right? And we'll do a new coffee name, and of course we can change this to a method reference. That makes that nice. And then I'm going to flat map that. We'll do a method reference again, repo save, because we're just going to pass each coffee to our repository to save. Now, if we stopped here, what would happen? Nothing, right? Because in a reactive model, unless you have a subscriber, unless someone's listening, nothing happens. It's very important so you don't waste a lot of time doing work. Your applications wait for somebody to be requesting that data, right? So what we're going to do is just do a subscribe. And then we can just leave it like that, or we can see what's going on. So I'm just going to log it. We'll just do a system. Boy, my typing skills went out the window. Print line. Need to shrink, I think. There we go. Now that's all right. But we're going to be restarting this several times, right? And each time we're going to be trying to add those same coffees. So we can do a little bit better. We really should do some cleanup work first, right? So repo.delete all. Now again, if we just stop here, this is an imperative code. So we don't know that this will finish before our population begins. So we don't know that everything will be gone before we start adding coffees. So how do we assure this? Well, we could do this. I mean, there is an operation called block. But if you find yourself littering your non-blocking code with block operations, you should probably question your life choices, right? That's not good. That's not a good habit to get into. What we really want to do is wait for an all clear signal. And we have an operation that'll do just that. We have a then many, which means that once everything upstream is done, then go ahead and accept a publisher and continue. We just happen to have a publisher right here, right? A flux is a publisher. I should back up and say, because I skipped over this, that in the reactive streams world, a publisher will produce 0 to n values. But there are times when it makes sense to deal with just a value, right? If you think of imperative Java, you have examples where you have let's say a method that'll return an object of type T, one value. You might also have a method that returns a collection of objects of type T, multiple values. In the reactive world, it's very similar. You can return 0 or 1 values. That in our world, in our parlance, is called a mono. You get 0 or 1 values. If you want to return 0 to n values, that's a flux. And some operations make sense in both cases, some don't, right? So it makes sense to partition those out. So a publisher, a flux is just one kind of publisher. Then many expects a flux, so that's exactly what we give it. And as you see, it goes down, you can go down here, and this is still a flux. So we do that, and now we have a then many, and we accept a flux, a publisher, and we pass it on. Now what we also want to do, because up to this point, what we're doing is printing out each one as we add them. It would be really cool if we could verify that that's indeed all we have in there. So we're just going to chain this. We're going to wait until they're all added, and then we'll do a repo.findAll. And that way we know for certain that that is exactly all we have in our data store. So let's go ahead and run that and make sure that no typos have crept in. Look at that. Okay, so we have coffees. Our coffees are stored reactively in our data store. No blocking has taken place. So far, so good. Okay, so now we have data. Now we can proceed. So let's go ahead, and we're going to create a service that we'll use to build everything else on. So this will be our coffee service. And we're going to inject our coffee repository so we can use that for our coffee service. Same thing. And then we want to define our internal API, right? We'll want to return a flux of coffees. So we can get all of our coffees, get all coffees. And it's pretty simple. You do a repo.findAll, straight pass through, life's good. We also want to return a particular coffee by its ID, right? So a mono of type coffee. Fine, there we go. Get coffee by ID. And we'll pass in our ID that we're wanting to look for, if you will. And we'll return repo.find by ID for that ID. We also will want to get that operational insight, right? We want to return a flux of all coffee orders, and we'll say get orders for coffee for a particular coffee ID, right? Return. Now, at this point, we don't have a repository for our coffee orders. This is kind of a live thing, right? As coffee orders come in, we just track them as they come in. We don't necessarily care about what got ordered 3 days ago. We just care about what's happening now. Now, we don't have that tracked. We don't have a way to store that at this point in time, so I'm just going to fake it. In fact, we don't even have orders coming in, so it's kind of irrelevant. But I'm going to fake it at this point so we can kind of see what would happen if we had those. So I'm going to use a flux and .interval. I'm going to use an interval of 1 second, 1 per second, and then I'm going to map that. And it's just a pulse, right? It's just a long value that comes out once a second. And I'm going to map that to a new coffee order. So new coffee order, we'll use our coffee ID and instant.now. Now, that's okay. But again, this is all about reactive systems, right? Building reactive systems and back pressure. What happens if you have a very slow consumer? Now, granted, at a rate of 1 per second, it would have to be a very slow consumer. But what if? Right? So we should always, as a practice, define what happens on back pressure. So we can define buffers of various sizes. You can determine what happens if you have an error. You can substitute in things. But if you need to do something at this point, you should have defined what that is from our service level. I'm going to just drop the intervening values. 1, because at 1 per second, risks are pretty low. 2, we don't care about what happened in the past. We care about now. So I'm just going to define that here, and we'll move on. Okay. Normally at this point, I like to write tests, right? To make sure everything works right. But we only have 11 minutes and 40 seconds. So I'm going to do just like we all do at work. I'm going to say that we'll test later. We will test later, right? Yeah, sure we will. Okay, so we'll assume it all works. I'm sure it's fine. And we're going to go ahead and create our external interface, right? So I'm going to create a REST controller, class, coffee controller. And I'm going to inject, in this case, my coffee service, because we're building our external API on our internal API. And once again, I'm going to use Lombok to do that heavy lifting for me. That's nice. And we're going to externalize our interface. So, actually, I should do this, right? Request mapping. We'll start this off at coffees. Coffees, spelling is a thing. And we'll do a get mapping. This is just off coffee's URL. And we'll return a flux of coffee. And we'll just say all. Return service.get, get coffees, all coffees. That's better. Okay, Very simple. Again, we've done the hard work already on our internal API, so this gets pretty simple. We also want to retrieve a coffee by its ID. So this will return a mono of coffee, right, by ID. We'll use a path variable to extract that ID, return repo.find by, oh, not the repo, service, right? Get coffee by ID, so nice. All right, and then finally we want to be able to get orders for a particular coffee's ID for that coffee orders. This will be a flux of coffee orders, and we'll just call this orders. Once again, a path variable for our ID, and return service.get orders for coffee ID. Much better. Okay. So this is good. Let's go ahead and just make sure this works. Then we'll build a client, and then we'll get onto the R socket, and then if we have any time left, we'll cover questions. If not, we'll do questions afterwards, so that's cool. All right. So that all seems like it should work, right? Oh, I don't have, let's see, terminal. Much nicer. Okay, so let's use HTTPy. That's curl for mortals, right? So coffees. Oh, so nice. Okay, so let's grab a particular coffee. I'll use Kona. So let's grab that, and that comes back fine. Now let's see what orders come in. Oh, I made one mistake, because in this case, only one, right? So in this case, what happens from a REST controller is that it waits for all the values to be returned before it bundles them up and sends them back in a document. We don't want to wait, because we know that our service is going to be providing one value per second till like forever, right? So what we want to do is say, don't wait for all of them, send them out as they come. I'm going to use server sent events to do just that. So media type of text event stream value. So that gives us the ability to go ahead and pass those through as they're produced. This is all about reactive, right? So that's good. So let's go back here. We'll grab our coffees again. Once we're started, we're started. Let's grab our Kona. And let's grab the orders for that. I actually need to make this a -s so we can stream those values as they come in and not wait for the last one, and everything works. Yay, right? Wow, that was anticlimactic. Yay, okay. I guess you guys expected my code to work first time out of the gate, right? Yeah. Doesn't always happen. I mean, once in a while, something goes off the track. So we have our coffee service. Let's go ahead and create our coffee client so we can, get to the other stuff as well. So I went ahead and, I created that. I'm going to unzip that. And we'll do a fairly simple one here off the bat here. So I'm going to go to my application, and let's see, I'm going to create a web client bean. So at bean, web client, return web client dot create HTTP. This is backed again to, I'm going to point this to our localhost 8080 because that's where our coffee service was. Yeah, we'll just stop there, right? And I should also go to my properties so we don't have any port conflicts, and we'll call this 8081, so that's fine. Port conflicts are bad. Now I need to go ahead and recreate my domain again, so at data, at all-args constructor, class, let's see, this was coffee orders, right? Coffee order, private, nope, private string, ID, and private instant when ordered. You have this. Okay, so that's good. And actually, I do know that I'm going to need the at norgs constructor. And then, of course, we need our coffees at data, at norgs constructor, at all-args constructor, class coffee, private string ID, and private string name. Sweet. All right. So at this point, we just need to create something that will allow us to test our connection. So I'm going to once again create a component, our class test client. And let's see, what do we want? We want to inject our web client, right? Client, and at all our constructor, so that takes care of that. And then we want a post construct method, void. Let's do this. All right. So we're going to use our client. we're going to add a URI here for coffees, and we're going to retrieve the contents of that. We're also going to convert that body to a flux. These will be our coffees, right? So our coffee objects, and then we're going to filter those. We're going to take each coffee, and we're just going to pull out one of those coffees. So coffee.getName.equals ignore case. We'll go with Kona. That's fine. And then I'm going to flat map the result coming out of that. We're going to take the resulting coffee, which should be Kona, coffee in this case, and we're going to do a get on that and add to the URI /coffees ID orders, right? And we're going to use our coffee get ID for that. Then we're going to retrieve that, and then we're going to convert that body to a flux of coffee orders. And then, just to make sure we've done everything right, we're going to subscribe and print it out. So system.out print line. Sweet. All right. That looks nice. Let's go ahead and run this and see if it works nice too. Nicely. Oh, look at that. Okay. Oh, ID null. So we have a problem here. So let's go back up here and we'll just troubleshoot this. This is a nice thing about working with a whole room of developers. So if we do this and we just comment that, let's go ahead and rerun this and we'll see what we get. We should get a list of all our coffees. Look at that. So that works. So now let's just filter that and we'll see that if we get Kona, oops. I uncommented the wrong stuff. Stop. Okay, there we go. So we're going to filter. There we go. Let's see what we get here. And meanwhile, I'm going to go back and double check my coffee names. Kona. Okay, so Kona's coming through. So we're flat mapping the coffee. Get URI retrieve. We're converting that to a coffee order. Oh, I know what the problem is. Silly me. You have to match the names. That should work a lot better. All right. So let's go ahead and rerun this. Hopefully this will work because I really want to get to the next part and we have 3 whole minutes left to do it. Okay, so that looks a lot better, right? So we see everything's working. Our client is interoperating with our coffee service, so that's great. I want to take you a step further, though, into RSocket, because as I mentioned, this is bidirectional. It allows you to do some really cool things. It gives you resumption capabilities and all that. So much more, just so little time. So what I'm going to do in this point, and I don't even have time to do the functional routing, such is life. There is a GitHub repo at the end, so that's fine. So I'm going to go ahead and create yet another controller here. But in this case, we're going to be dealing with RSocket. So the first thing I want to do, actually, before I forget, is go to my application properties, and I'm going to set my RSocket port as 8901. And that way, we're going to address a different controller here. So this is our controller here for RSocket. We'll call this RS controller. And we're going to keep this simple to start off with, right? So I want to create a message mapping here, and we'll just call this for coffees. And we're going to return a flux of coffees. Oh, and I should actually private final coffee service so we can use our service and at all our constructor, so we inject that. And we're just going to supply coffees. Return service.get all coffees. So that's pretty simple, right? See, RSocket, when we Springified it, we made it a whole lot easier to consume. There are some amazing capabilities, but it wasn't always that easy to consume. I like to think of the Spring team as the Apple of enterprise software because we come up with some really great stuff. We also take other things that we're creating as an industry and make them so much easier and better to consume. And that's what we've done here with RSocket. So I'm going to go ahead and restart that, and we'll go over to our client. And our client, we need to do a few things. I'm just going to disable this so we don't have that popping up when we start up again. So we need to create another bean, and this will be for our RSocket requester. We're going to return an RSocket requester. So this will be our requester, and we need to get a builder here. We'll call this builder. We're going to pass that in, and then we're going to use that to, let's see, return builder dot connect TCP. Again, dead simple, so we're pointing to localhost actually for this, and we're using what? 8901 for our port, and we're going to block and create that. So now, let's go ahead and create an RSocket client here. So this will be a REST controller. We'll use actually class RS controller here as well. That's fine. And here, we'll do a get mapping for coffees. Coffees. We want to return a flux of coffee. Coffees. Ease. And let's see. So we need to do we need to inject our requester, right? So private final RSocket requester, and once again, Lombok to the rescue. We'll take our requester and we'll route that, and we're pointing to coffees because that's what we did to create our message mapping here. And then we will retrieve our flux of coffees. Right, let's try that and see if I've missed anything. Because this is where it gets exciting, right? This is an example of that request, let's see, what is it? It's not request, it's not fire and forget, it's not request response, it's request stream. Because we're getting back a finite stream of coffees. We only have a handful, and that's fine, but it works. So I'm going to hit that endpoint, 8081 for my client, coffees. And we see that we're getting that back, but we're getting it back over RSocket. And that's pretty cool. Okay, that's not bad. I think we can do better. So let's go ahead and extend this. I'm going to now do a get mapping, and we're going to do orders for a particular name, a coffee name. This gets a little trickier, right? So a flux of coffee orders. And let's say orders. And let's see, so we want to make this a path variable, string name, right? String, typing counts, and there we go. So return requester dot route, and we're going to take our, what we want to do is tie this together here with orders dot concat, and we'll take that name, and we'll retrieve a flux of coffee orders. So let's hope that works. I'm going to go back and now fill in the supplies here. So message mapping, and this is orders dot name. So we'll return a flux of coffee order, orders, and in this case it's a destination variable, string name. This should work, right? So we're going to do a service dot, and we don't have anything here, so we need to actually fill that in. But we can go back rather quickly and do this in our repository, and we'll add a method here. So this will return a flux of coffees, a mono of coffee, right? Find coffee by name, string name, right? We want to be able to do that. Now our service, we want to build this out a little bit. So we want to return a mono of coffee, get coffee by name, right? String name. Now return repo.find coffee by name. If that is empty, right, we should be able to do something. So we'll provide a default. In this case, we'll do 1, 2, 3, 4, 5, and my favorite coffee. So now we have a few things in place. Let's see, new coffee. Much better. Okay, so at this point, we can go back up now and do our service.get orders for coffee. Get coffee by name. We'll pass our name, and then we'll do a flat map mini to take that coffee, right? And we'll do a service.get orders for coffee, and we'll take the coffee.get name. Sweet. Okay, so this should work, right? This should work. Okay, let's try that. And if I've missed anything, well, the source code is in the repo. Okay, so we're back up and running on our service. Let's go back and restart our client. And actually, yeah, we'll try our coffees endpoint to make sure that still works. It does. Let's go to our orders and Kona, right? Oh, no handler. Ooh, okay, so, well, that is unfortunate. It's also very easily solved. Let's restart that. Oh, oops. No pressure, right? No pressure. All right, let's go ahead and restart that. Okay, that should work. Now let's try that again. Ah, wow, I hate it when you're just dying up here. Okay, so let's see. For whatever reason, oh, that's my bad. We're not streaming. -S. Let's see it like it's supposed to happen. He says, and then nothing happens. Okay, well, with that, I am way over time. I don't want to continue this. I actually do have all of the source code in the repo that works just perfectly, of course. This has got to be something that I've just glibly slid over, and for whatever reason, it's just not happening here. So, with that, let me go back to my slides. And I'll point you to the said repo, right? So everything starts here at diving into Reactive, my DIR GitHub repo. That's the master repo that actually points to all the working code out in the Coffee service, Coffee client. There are also Kotlin versions from a previous talk that I have not updated, but they're there if you want to take a look. If you want to know more about the Reactive Streams initiative or about Project Reactor, they're there as well. If you want to just follow me and chat with me, I'm on Twitter, MKHeck. Please do, and if you have any questions, comments, or feedback, please see me after. If you can't see me after, if you think of them later, ping me on Twitter. My DMs are open as well, so thank you very much.